Hello everyone, my name is Ziggy and I will be demonstrating how to install, configure and use Git in the Linux command line. Throughout this tutorial you will see that I use Debian to demo the practical side of things. The principles however are the same for all distributions. So let's start with some theory and take a closer look at what this Git thing really is. Git is an open source version control system designed by Linus Torvalds, the Finnish software engineer who is most known as the creator and longtime principal developer of the Linux kernel. A version control system like Git allows team collaboration on files, not only code, and protects the user from accidental changes to one or more files, data loss in case of a computer crash, and enables the ability to revert files to a previous state or version. Git will also detect source conflicts in case of multi-person collaboration and help the user resolve these. Let me run you through the process of the Git workflow. Assuming Git is installed in your local machine, the first step would be to obtain a repository. A repository is not only a collection of your current files, but also has pointers to previous states and parallel pathways. It allows you to have multiple versions of a folder and files at any given time. For a website, for example, this could mean that the current stable version is sitting on a production branch, most often referred to as the master branch, but an improved development version is also contained within the zip repository. By switching between these branches, you hop between different parallel states of your files. In order to save these states, we have to commit a change or make additions or deletions. A commit is a snapshot of a period in time on a specific branch, which captures the current state. This will allow us to revert to an earlier state should we ever have to choose to, or perform these tests before merging our changes into an actual production branch. One important thing to note though is that commits are initially made on a local machine. Git can be used on one client without the need for a remote server. This is useful for people who don't want to take advantage of team collaboration or have a remote backup. It is, however, highly recommended to also set up a remote clone, since this will increase reliability and can be done free of charge using a service such as GitHub. The action of uploading one or more commits is called a push. So now that this is clear, let us take a look at how to install Git on Debian 8. Git is available on the Debian Package Manager Aptitude. To make sure its source repository is up to date, we run the command apt-get update. Once that is complete, install the Git protocol by executing apt-get install git-core. The Git package is also available under the same name on the Yellow Dog updater, better known as Yum. Once the Aptitude package has been installed, Git requires very little configuring. There are two global parameters that, although not mandatory, I always recommend you set. This is the name of the user employing Git and this person's email address. The commands are git config global user.name, followed by the name enclosed in double quotes, and user.email, followed by the user's email address. If you use Git in conjunction with GitHub, I would strongly recommend you use an email address that is known to GitHub so that your commits can be linked to your profile. Once you have set these parameters, they can be verified by executing git config list or by using your favorite text editor by opening /root /dot gitconfig. Now that we are set up to use Git, let's clone our first repository from GitHub. I'll navigate to the repository I wish to use in GitHub and copy the HTTPS URL to my clipboard. This URL points to the Git repository in a remote server, in this case GitHub. This can also be your own Git server, as demonstrated later on in this tutorial. So let's go back to our Debian CLI and create a directory to store our repositories in. The command to download or clone the repository goes as follows: git clone followed by the HTTPS URL of the server followed by the destination folder that should be created. For the purpose of this demo, we'll use HTTPS to verify my identity, but I will show you how to set up a certificate later on. After Git pulls up the contents from the server, we can verify by navigating into the newly created folder and executing an ls-l. To bypass the need for authentication, a SSH key can be used. Let's generate a key pair now. When doing so, the system will create both a secret private key and a public key. I will not divulge by explaining asymmetric cryptography too much, but you should know that the private key is absolutely secret and only known by you. Any data that is encrypted by the available public key can only be decrypted using your private key. The command to create a RSA key pair is ssh-keygen. We can pass several parameters, being -t to specify RSA should be used as a encryption standard. -b will set the numbers of bits stored in the key. 2048 bits is usually sufficient for RSA, but in this example we'll use 4096 bits. We can also pass a comment by using -C. Once the key has been generated, let's add this to the SSH agent so that we don't have to worry about the key later on. Firstly, load the SSH agent. The command shown here can also be typed as eval /ssh-agent Then use ssh-add followed by the location to your private key we just generated. In Debian, these are usually stored in the hidden folder .ssh, hidden within the /root folder. The only step remaining now is to associate your public key with your GitHub profile. You will then be able to clone a GitHub repository using SSH without the need for a username or password. That is, assuming you have chosen not to set a password when generating the key pair. Committing your files and pushing these to a remote server is easy. I have created an empty GitHub repository to demonstrate how to do so. This time, however, instead of cloning it, we'll create a new one locally and add the remote server manually. You can do this very easily by creating the folder you'd like to use as a repository, stepping into this folder and executing git space init. This command will automatically create an empty repository ready to be used and accepts a wide variety of parameters. One of these parameters is --bear, which will create the repository as a central non-working entity that cannot be used to commit changes to. You can see it as a storage facility opposed to a development environment. Before we start committing though, let's add GitHub to the remote server list so that we can push our files to an external location. You can do this by typing git remote add followed by the name of remote, usually origin, GitHub, or a server name, and the SSH destination. To view a list of remotes, execute git remote-v. Now that we have a remote server set up, we can create our first file. Once you've done so, stage your file or files by typing git add followed by the file name, or simply git add period to stage all new, changed, or deleted files. You can now execute git commit, which will prompt you with the question if you'd like to include a message. This is highly recommended as it will allow you to pinpoint what this commit does exactly in the future. Since you have committed, the change is now contained within your local repository but not yet reflected on GitHub, as shown here. To publish your latest commits, which is definitely not limited to one, use the git push command followed by the remote name, which is GitHub in this case, and branch you'd like to push. The branch, in this case, is called master by default. Now you know how to install and configure Git on a local machine, create a new repository or clone an existing one, how to generate a SSH key pair, and how to change, stage, and commit files and push these to a remote server. Like I mentioned earlier, GitHub is a really powerful and great asset. It is not the only solution out there if you want to take advantage of the remote repositories though. If you have the resources to set up your own Git server, you can very easily and efficiently create your own development environment. I'll show you how to set up a bare repository on a second Debian-powered machine. Like on the client, the first step would be to install the aptitude Git core package on the server. Configuration is not needed if you choose not to use this machine to commit changes. Instead, create a new user and home directory. This account will be used to connect to this server from local machines. Make sure you have a working and configured SSH server running to make this possible. Once you've created the user and directory, change the ownership of this folder to the user you just created, in our case Git. We use the chown command for this. Use the recursive -R parameter to change all subentities as well. You should now generate a new SSH key pair for this server. Since we have already done this earlier in this tutorial, we just use the one we already have. Copy the generated public key over to the new authorized keys file within a new hidden .ssh folder within the home directory for the new user you created moments ago. Feel free to use the command on the screen or split it up into multiple subcommands. It really doesn't matter in the end. Once the key pair has been copied over, create a new bare repository into the user's directory by creating a new folder executing git init --bare init. Make sure to change the ownership of the entire user folder again, since the command has been executed as a root user in our case, which will restrict access for the newly created account and thus rendering the repository unusable. Now move over to the local machine and initialize a working repository. Once again, you can do this by executing git init. The remote can now be added, git remote add server-2, which is the name of our server, followed by the SSH connection and path. To verify if our repository works, I'll create two files and stage, commit, and push them to our remote server. Let's move out of our repository now and clone a copy. Git clone, followed by the SSH location of the remote repository. When stepping into the clone repository and executing a list command, you will see that our newly created files appear there. So thank you very much for watching this brief tutorial on how to use the Git CLI. Feel free to leave me some feedback in the comment section below, I would really appreciate it.